What are the biggest misconceptions about relativity theory? When we think about relativity theory, many questions arise. One of the most common misconceptions is that Albert Einstein created this theory entirely from his imagination. In truth, he built upon earlier scientific work. Scientists like Henri Poincaré had already explored ideas related to the invariance of physical laws and the speed of light. Einstein synthesized these concepts and expanded upon them, rather than inventing them from scratch. Another misunderstanding is the belief that relativity only applies to objects moving at speeds close to the speed of light. While special relativity does focus on high velocities, its principles also influence everyday experiences. For example, time dilation and length contraction occur, even if we do not notice them in our daily lives. Many people also confuse the nature of the speed of light with the expansion of the universe. It is commonly thought that nothing can move faster than light. However, in cosmology, the expansion of space itself can cause distant galaxies to recede from us at speeds greater than light. This does not violate relativity because the galaxies are not moving through space faster than light. Instead, the space between them is stretching. Another misconception involves the idea of absolute rest or ether. Before relativity, physicists believed in a medium called the ether, which was thought to carry light waves. The famous Michelson-Morley experiment failed to detect this ether, leading to the understanding that no absolute frame of reference exists. Relativity replaces this notion with the principle that the laws of physics remains the same in all inertial frames, making the ether unnecessary. Energy conservation in general relativity is also often misunderstood. While energy conservation is a key principle in physics, in curved spacetime and over long timescales, energy is not always conserved in the traditional sense. The expansion of the universe disrupts certain symmetries that underpin conservation laws. Interestingly, Einstein himself was not fond of the term relativity. He preferred to call it the theory of invariance, highlighting that the laws of physics do not change across different frames of reference. Understanding these misconceptions is important because it clarifies how relativity theory evolved from earlier scientific ideas. This theory marks a significant shift in our understanding of space, time, and energy. It also shows how our views changed from classical ideas of absolute space and time to a framework where measurements depend on the observer's state of motion. This shift has had a profound impact on modern physics and technology, such as global positioning system satellite systems, which must account for relativistic effects to maintain accuracy.